This is Euterpe, Greek goddess of music and poetry. She's a figurehead off of what's currently called the Star of India here in San Diego. Euterpe was hand carved by a Scottish woodcarver back in 1863. She's 158 years old. We found that in the process of repainting her that she was having some issues with some rot. So we took her off the bow of the ship. We've brought her into the hold where she's protected, and we're able to do a restoration, get her back to her original shape. Our ultimate goal is to answer the question, do we need to have a backup, a replacement? And we decided that now is the time to do it, and the best process to use to come up with a replica would be 3D scanning, and so the possibility of a 3D print. And that led us to Braxton and his program, and I'll let him explain how that is the next step.
Thank you, George. What we have here is we have a 3D structured light scanner that students actually work with the scan data. The structured light scanner is manufacturable quality scan data, and what that means, it is accurate down to plus or minus 40 microns. So those of you microns would translate out to 2 to 4 thousandths of an inch. So all the extreme detail that we're seeing here on the model is captured by the structured light scanner hitting the model. What we do with that data is we take that data and then we put all the scans together. Here we've taken about 300 scans, full 360, putting the model in various different positions. So we get all the nooks and crannies, all the undercuts. So it's a very detailed process. For this model, we've estimated about 3 days to capture something that's as tall as this, 5-6 feet tall, the size of a human with all the detail, the dress, the hair. So that gives you an idea of, you're looking at a good 24 hours of scanning. Once you do get that scan data, you can go back to your desk, and this is where students get the workflow experience regardless of whether or not you're learning this on Zoom, online, or in person. The big piece of it is understanding the digital thread or the digital twin workflow. And what we mean by that is the data comes in as points, then translated into an STL model that then goes into the target CAD system of SolidWorks, which we teach at UCSD. SolidWorks is one of the front ends to the engineering curriculum in being able to get your certificate for 3D, to include 3D printing, and then of course reverse engineering and 3D scanning. So all three courses really intertwine together to give you a full workflow experience. So at the end of the curriculum, you're able to actually go out and be valuable to a company, that you really understand what it means to move digital data through the whole pipeline or workflow of bringing your models to either machining it on a CNC machine or 3D printing it, the time frames involved. So when your boss comes and talks to you, you can actually respond back with a real answer. So when they say, how long can I have that on my desk in a 3D printed form? So then you're looking at 3 days to scan, 2 days to do processing, and then it takes 5 days to print something like this. It's just a miniature scale. So you're really, the hours involved to bringing these types of projects to life actually involve time and understanding the scale of the types of models that you're working with. So that gives you a really nice compact view from the top down of how this data moves and how you get to learn it at UCSD.